typically they're going to be all about matrices. So let's take a look. Why don't we go ahead and dive into this first one over here with boxBlur. All right, so boxBlur is asking us this.
Last night you had to study, but decided to party instead. Now there is a black and white photo of you that is about to go viral. You cannot let this ruin your reputation, so you want to apply boxBlur algorithm to the photo to hide its content. The algorithm works as follows. Each pixel X in the resulting image has a value equal to the average value of the input image pixels values from the 3 times 3 square with the center at X. All pixels at the edges are cropped. As pixels value is an integer, all fractions should be rounded down.
Okay. Interesting. All right, so basically the idea is that we want to apply a box blur to this image. So we're just sort of taking the average. It's a black and white photo. Basically, I guess these are sort of representing like the brightness of each pixel sort of thing. And if we take a look at our constraints, so 0 to 255. Yeah, okay. So it's like an RGB value, I guess. Anyway, okay. So how are we going to do this? Well, basically the idea is that we want to be able to take each of these pixels that have enough neighbors, like that sort of form a 3 by 3 square around them, right? So the 7 here is kind of like the only applicable one. But basically the idea is that we want to take everything from in the vicinity, everything that's in that 3 by 3 square, and we want to take the average of that and then round it down. And then that's what's going to be used as our new pixel in our new image. So our new image is going to be smaller than the original. We're basically going to lose a pixel off of every side. And so the width of it is going to be the same as the original width, -2. The height of it will be the same as the original height, -2. Okay, so let's take a look at some of the other tests in here. Okay, so that's another example. Let me just paste that up here so it's a little easier to see. Okay, so now we've got this matrix over here. Let me just kind of space out the values a little bit. Yeah, okay. There we go. That's a little better. So we can see all the numbers in here, and basically the idea is that since this one sort of has this 3 by 3 square around it, you know, this area like that, and then this next one, the 9, also has that property. Well, that means we'll be able to have 2 pixels in our blurred image, and there they are. So they're just taking the average of what's in the vicinity. Okay, so there are a few ways that we could take a look at this problem. I mean, one way is that we could sort of create a new matrix to fit our blurred image. And then from there, we can find the values for each of these pixels, like the new pixels, by taking a look at kind of the surrounding region in the original matrix image. Okay, so let's try that first of all. So first of all, I have a feeling I'm going to have to use the dimensions a few times here. So I'm going to say column... Should I call it column length or column height? Column height, I guess I'll call it, just because, you know, it makes it clear that we're talking about the vertical. Okay, so it's going to be image.length. And then we're going to let row length be image at 0.length. This is kind of a trick that we've pulled a few times here. We don't know exactly how big the matrix is going to be. We know it's going to be somewhere, both sides are going to be somewhere between 3 and 10. The main thing is, you know, there might not be a 10th row, but there's going to be a 0th row, guaranteed. And I guess there's also going to be a row 1 and row 2. So we could just as easily use that, but 0 is definitely going to be there. It's kind of conventional, so we might as well just use 0. So basically the idea is column height is telling us, well, how many elements are going to be in each column. Row length is telling us, well, in one of the particular rows, and in all of them, since they're all going to be the same length, how many elements are there. Okay, so we've got those. We're probably going to use those, I would imagine, more than once in our algorithm here. So let's get started. Basically, we want to build the frame for the new image. And when I say that, I basically mean do a new matrix. All right. And then after we do that, we want to populate the frame with the blurred image. Yeah, okay, that's basically it. And then at the end, we're just gonna return our blurred image. What's blurred image? Well, I guess we should talk about that. So let's put it right in here. We'll say let blurred image be assigned the value of this empty matrix. And we've been looking at a few ways of doing this. You know, we've been talking about like creating a new array by doing something like new array with let's say call height, and then doing like a dot fill on that and putting something in there. But I found out recently, apparently fill is not very well supported, so we probably want to stay away from that. The other thing is they tend to say like, you know, use object literals when possible, so probably something like that would be better than doing the new array thing. Something I did find out is, it turns out, this is kind of silly, but it turns out it's possible to do this. So we can say, sorry, not like that, like this. We can say blurred image dot length. And then we can give it a value. We can say it's equal to 5, let's say. And then from there, we could do blurred image dot fill, and we'll say 0. Just make it all zeros. And look at that, it actually responds to that. So that's kind of weird, like that we can just tell it what its length is going to be and then let it fill it from there. But again, we don't want to use fill, so maybe this is a bit of a moot point. We're not really going to get into that anyway. So we're going to do this kind of like the old school way. We're just going to fill it up manually. So I'm going to say for, let's use x and y just for coordinates. So let x be assigned the value of 0. X is going to go to, I guess, call height minus 2. Because remember, we're chopping 2 elements off of both dimensions. So then I'm also going to say let y be assigned the value of 0, and y is less than row length, again minus 2, y plus plus. Okay, and then what are we going to do with this? Well, basically for each x, we want to make a new row. So let's do that. I'll just say let row be assigned the value of an empty array to begin with, and at the end of each iteration of the x loop, we'll say blurred image dot push row. Okay, great. What's going to be in the row? Well, let's find out. So basically, for each of these, I guess for now we can just do like a row dot push 0. I just put in a 0 for every value of y here. And let's see what this is giving us. Is this actually filling up the matrix the way we want it to? Okay, so the frame was the right size here. Obviously it doesn't have the values in it yet, but okay, that one was the right size. Is this one the right size? Yeah, looks like it's the right size. It's gonna fit all the data. Okay, perfect. So we're building the frame for the new image. That's working, no problem, looks good. Okay, and maybe we can even tighten it up just a little bit because we're gonna have a lot more code to write. We wanna just sort of fit it all together for now, just so we can see where we came from. All right, great. So nice, that all fits. We've got our blurred image here. And something I want to point out, this might not seem like a big deal or anything, but it's kind of importance, the fact that these rows that we're putting in here, they're all unique. They're not just like a copy of the same thing. And to demonstrate that, I just want to say blurred image at 0 is assigned the value of, let's just say 2. So basically the idea is that the first element in the matrix should be 2. Now we've seen in some instances before, if we tried to just do something like, to have a row and then just push that same row in each one, what we would find is that later on, when we get into multiple rows, it's not just this one being affected, it would be all of them. So just to show that each of these rows are unique and that we can interact with them uniquely, I just wanted to use this quick example here, but we're not actually going to do that. So what are we going to do? We're going to populate the frame with the blurred image. Okay, so basically the way I want to do this, and again, I'll just grab this matrix as a quick visual here. So then what do we want to do with this? Okay, well, we'll space it out again just to make it easier to look at. Okay, great, that wasn't too hard. So what we want to do is, we know that we can form, we can get a new pixel with this one here, that one there, and that one there, because those are the only ones that actually have enough of a border to be able to actually calculate these things. Okay, so basically that means we're going to start our iterator for populating this thing. We're gonna start it at 1 instead of 0, and we're gonna go all the way up to length -1. Well, technically length -2 is what we're gonna go up to. Okay, so hey ATD, good question. So basically, why are we doing row length -2 here instead of doing like regular row length? Oh, you got it? Okay. Well, for anyone else who missed it, basically the idea is that we're cutting off one from each side just because, yeah, we wouldn't have enough information to actually blur the pixel. Okay, so for this one, yeah, we want to start at 1 for populating the frame and then end at like length -2. Basically, it's not going to get to the length -1. Okay, so we'll clear that, and then let's do some more for loops. So we'll say for let x be assigned the value, oh sorry, I said I was going to make it 1, so there we go. X is less than call height -1, x plus plus, and then we'll put another one inside here, which is going to be the y loop. It's also going to start at 1. It's going to go to row length -1 and y plus plus. Okay, great. So what are we going to do in here? Well, basically the idea is that we already know that anything that this loop is going to cover, you know, like it's not going to get like the 7 up here. It's not going to get the 6. It's only going to get these two and these two. So we already know that anything in here is going to be surrounded with enough pixels to be able to blur it, to be able to take an average out of 9. So we're going to say let sum, first of all, be 0, because basically what we want to do is add up all the neighbors. And when I say neighbors, maybe that's a bit of a confusing term, because I do mean it includes this pixel. So that's maybe important to mention. Anyway, so the sum starts at 0 and we want to add up all the neighbors. So how could we do that? Well, we could do something like, you know, sum plus equals image at x minus 1, y minus 1, right? So basically if we're starting here, then x minus 1, y minus 1, so we're adding this one. And then we could say sum plus equals image at x minus 1, and then just y. We could say sum, let me move my cursor, sorry, that was in the way there. Image at x plus, x minus 1, but then y plus 1. Okay, so we're basically saying we're starting here. We want to get that one, and that one. But then that's not all we want. We want the next row, right? So that would be image at x at y minus 1. We'd have image at just regular x, regular y. We'd have image at x and then y plus 1. I mean, etc. So do I have to do all 9 of these? Well, I mean, look, we're repeating ourselves a lot here, so maybe we could put this in the form of a loop. So notice what we're getting here, like we want to subtract 1 from each of them. We want to not subtract 1, so we basically want to add 0. And then we want to add 1 as well. So y had a -1, it had plus a 0, and then plus a positive 1. So we basically want to do that for both of them. So I'm going to make some new for loops. I'm going to say for let dx be assigned the value of -1. dx is less than or equal to 1, dx plus plus. And then for let dy be assigned the value of -1, dy is less than or equal to 1, dy plus plus. And then from there, we could say something like sum plus equals image at x plus dx, y plus dy. Okay, so basically, this is going to cover absolutely all of them, right? We're going to have x and y starting at a particular value. And then from there, dx and dy are going to cover all these combinations of -1, 0, and 1. So it's going to get every single one of the neighboring pixels, including itself. Okay, and then that's sum. So what do we want to do? We want to do blurred image at x at y is assigned the value of sum. Let's do that for now, and we'll see where that's getting us, if it's working. Execution time exceeded. Uh-oh, why would that be? So we're getting an infinite loop somehow. Is there one that's not completing? Oh yeah, this one that says dx, it should say dy. Okay, sneaky. All right, hopefully this okay, so it didn't time out, but it had an execution error. It says can't set property 1 of undefined. And where's that happening? It's on line 29. You know what? I'm realizing something here. When we're putting this back into blurred image, keep in mind blurred image in this example for the first test only has one index. It's only 0, 0. The thing is, x and y are not getting to 0. They start at 1. So we actually have to cut off 1 from each of these just to make sure that it actually matches up here. And that's just because of the different sizes of our two frames here. Okay, so what are we getting now? Oh, we're getting 15 here. All right, so it's going to the right place. It's not the right number, but we'll talk about why that is in a second. It looks like these numbers are kind of like, 9 times what the expected values are. So maybe that's a bit of a hint here. And yeah, basically the idea is that we're trying to take an average, right? So we want to take all these things, sum them all up, yeah, but then we want to divide that by 9, and we want to take the floor of that. So we're not just going to add the sum, we're going to add, I guess we might as well just do it this way, just to be proper about it. Let average be assigned the value of math.floor of sum divided by 9, and then what we actually want to put in here is the average. Okay, so let's see if that works. Ooh, look at that. It's working. Okay, so that's nice. We can bring this a little further up. We don't need so much space in between there. So this is good. We've got an algorithm that's working. It's passing all the visible tests. And here, I'll just bring those a little closer together. Can't fit the whole algorithm on one window right now, but that's fine. So let's try submitting this. We'll see if it passes the hidden tests, and we'll go from there. Great. Okay, so that passes all the hidden tests. But we're going to do some more stuff here. We're not done with this because there are two issues with this, I would say. Okay, first of all, the first issue I have with this is the fact that we're kind of building out this frame. We're creating this new frame, and then we're leaving that alone. And then afterwards, we're going down here and we're populating the frame. We're putting in the stuff. Thing is, like, we're going through a set of nested for loops with x and y here, and then we're going through another set of nested for loops with x and y. I guess what I'm trying to say is, if we're going to go to the trouble of building out the frame, and then we have to populate it anyway, like every 0 we're pushing in here is then getting replaced with an average down here, we might as well just do it all together. We might as well just do, why bother with another set of nested for loops with x and y if we already have them up here? So we're going to try to do that. We're going to try to do it all in one set of loops here. I'm going to comment this one out, and we're going to retry above initially with the same thing, I guess. So I'm just going to put that in there. Okay. Yeah, ATD for sure, my man. I mean, matrices are definitely going to be intimidating, but look, if you got any questions, if there's any like particular aspect of it that's giving you some issues, definitely feel free to let me know. Okay, so just to review what we've done here, we wanted to create this blurred image matrix, so like the frame, so to speak, for our new image here. It's kind of frustrating that they went with an example that just has one element in the new matrix there. So yeah, something like this sort of shows us a little more clearly. Basically, the idea is that this loop right here, or this set of loops, the outer one is for like pushing these new rows in, and then the inner one is for actually creating those rows. So then we want to not just use a 0 here. This is where the change is going to happen. Instead of pushing the 0, we're going to push the average like we saw down here. So could we just do this? Like, could we just grab this thing, take it out of there? Maybe I'll try to salvage the comment for now. But yeah, can we just take that out of there and then put it right in here? Would that work? Is that going to be possible? Let's see. So the sum is 0. We want to add up all the neighbors, including this pixel. We eventually want to push. So yeah, instead of this part here, let's just push the average. Push the average. There we go. And we'll clean that up a little bit. And let's take this comment and put it up here, I guess. Populate the frame with the bird. Well, no, we're kind of doing both. So let's just put them together like that. Okay, great. Build the frame for the new image, building a new matrix, and populate the frame with the blurred image. Great. Okay, so is it working? That's the question. Let's run this. We'll see what happens. And oh no. Can't find property -1 of undefined. Well, why are you trying to find property -1 anyway? That was not part of the deal here. Well, here's the reason. Check this out. Remember down here, we were kind of guaranteed to have neighbors that are within range. But the reason for that was because we were going from an x value of 1 to column height -1, a y value of 1 to row length -1. So we're going to have to adjust this. I mean, basically, we're looking for, okay, since x is not starting at 1, when we're talking about this one, when we're looking for the value of our blurred image at 0, so x value 0, y value 0 here, well, we're talking about this, this, and this, right? So we're talking about indices from the original that would be 0, 1, and 2. And same with the columns, 0, 1, and 2. So it's not that we're subtracting one. Like if we want an x value 0, y value 0, it's not that we want to subtract 1 from that 0, keep it the same, and then add 1 to the 0. It's that we want to, in this case, add 1 to it, and then add 2 to it as well. And so again, it's just a result of the fact that the frames are a different size. You know, if we had that like same padding around this one, like if we were just, I don't know, had zeros all around it or something, then we wouldn't have to worry about this business over here. But since this is one where they are different sizes, we're going to make the adjustment right here, and we're just going to say from 0 to 2 instead of from -1 to 1. And is that enough to fix the issue here? Yeah, it is. Okay, great. So that's a little nicer. Yeah, I like that better, I think. It's kind of getting it all done in one pass here. So yeah, I think that's probably better. Is there anything about it that's not good? Or no, it looks pretty good. Okay, awesome. Great. And also, you know, like, I guess in this algorithm, it looks like we actually aren't using these more than once. So technically, like, we can make this one a little bit smaller. Instead of call height, we could just replace it with this. And then for row length, we could replace it with that. Because it's not like we're making any other comparisons to that later on. So yeah, that's still working. Is it better like that? I don't know. It's up to you. But it's working. That's the main thing. So this is definitely a way that we could do it. Is it the best way we can do it? You know, it's funny. I thought about this a lot. Like this was out of all the tasks we've gone over so far, This is probably one that I've put the most time into beforehand, just trying to come up with a game plan for how I was going to try to convey this one. And the thing that kind of still rubbed me the wrong way about this particular example, about this particular algorithm here, is the fact that we're kind of repeating ourselves a lot. So what do I mean by that? Well, let's look at an example. So I want to take this matrix, and I'm just going to clear what we have on the screen here. We're going to paste that in, and we're going to space it out a little bit. In fact, let's space it out a lot. Yeah, 2. Because I noticed that page marker pen I've been using is it's a little wide. It's kind of got some thickness to it. So actually, I guess I could turn that down. Oh, great. All right, so here's the issue. When this is like our target index, actually, hold on a sec. That's too similar to the actual color there. Okay, so when this is like our target element, when this is the one that we're trying to blur, this is the pixel we're going after, then basically we've got to grab like this one here, this one here, this one here, that one there, this one here, that one over there, as well as itself, right? And then when we move on to the next one, let's say we want to take a look at this 2 one over here, right? We want to blur that down. So which pixels do we need to take a look at? Well, we need to look at this one here, this one here, this one here, that one there, and that one over there. The thing is, this is getting pretty messy, and the reason is because I'm circling the same numbers over again, like there's 6 of them that end up being common to both of them. So like, I kind of feel like, why bother looking those up if we already know what the values are? So maybe there's like a different way to do this. And I actually had kind of a hard time with it. I was trying to come up with an algorithm, and I was thinking, well, maybe just get the sum from each of these, like this first box of 9 here, and then shift it over, just subtract these 3 from the sum and add these 3 to the sum. And so that was kind of clever, but then the issue was, well, what about when we go down to the next set of rows? Because then, we could say, yeah, well, get like this next square, like this right here, you want this square? Well, just subtract the sum of those elements and add the sum of these elements. And so it seemed like, yeah, well, that should work, right? But then when we want to move on to the next one and we want to like, add this and subtract the ones over here, well, it's not going to remember the ones over here because it's remembering basically this as its previous column. So that was fraught with issues as well. And, I thought, well, what if you just had like a moving viewfinder kind of thing, and you just had this like 3x3 matrix, and the values that it takes on are just based upon values within the original image. But then I figured, like, that's going to put a lot in the memory. Like, why bother with a second matrix? Like, you're already building another matrix here. So what I finally settled on was a bit of a different approach, and I sort of want to illustrate it. Let's look at it without any numbers. Now, thankfully here we've got this square grid. You can sort of faintly see it, but I'm going to zoom in because we're going to use some really, we want it to be not super small, I guess is the main thing. So basically, let's say we had a matrix that was, I'll say 4 rows. Yeah, 4 rows. And then let's go with 5 columns. Is that good? 1, 2, 3, 4, 5. Yeah, okay, great. And then we'll close it off there and here, right? Okay, so we've got a whole bunch of squares in here. So, the way I think I want to do it now is this. So we're going to have, let's say in blue, we'll do, is this the minimum thickness? Yeah, I guess it is. Okay, so in blue, we're going to be looking at these, right? And these, when we take the average of these ones, it's going to give us basically like, that pixel in our new matrix. And then this next one over here is going to give us that pixel. And then the next one over is going to give us the pixel to the right of that. So that's going to give us this one. And then we'll look at the next row. Do we have enough colors? Yeah, brown, underrated. Okay, so here we go. That's the next box. So it's going to give us that pixel. And yeah, purple, there we go. This one is going to give us this one, and then finally, great. This is going to give us that one over there. Okay, awesome. Glad we did that. All right, so yeah, doesn't that look beautiful? Okay, so the point is, as we're going through these, I want to switch it up a little bit, because basically the way I was doing it before is I was saying, okay, let's target this pixel, and the way we'll do it is we'll grab this one, we'll grab this one, we'll grab that one, we'll grab that one, that one, that one, that one, that one, that one. Okay, and then when we wanted to move on to the next pixel, let's say this one, I was like, okay, grab that one, grab that one, grab that one, and we're kind of repeating ourselves a lot. So we want to not do that anymore. So instead, we're going to do a bit of a paradigm shift here. We're going to flip this around, and instead of looking at sort of like focusing on this one to begin with and then seeing, you know, what we can get from the original, now I want to start with the original. I only want to look at every element in the original once. Okay, so how are we going to do that? Well, basically we'll say, let's take a look at this pixel. Which of the blurred pixels is affected by this one? And it turns out, just that one. Okay, so now let's say we wanted to look at this pixel. Well, which one of the blurred pixels is this one going to affect? Well, it's in the blue square, but it's also in the green square, so it's going to affect both of these. All right, and then we'll look at this next one. Well, that's affecting these three. Okay, great. Let's take another one. Let's say that pixel down there. So notice this one it's within the green square. It's within the yellow square, it's within the purple square, and it's within the fuchsia square. So it's going to affect all four of those pixels. Okay, so maybe we can talk about like the relation between these two, the indices of these things over here versus the indices of these things over here. So if our index is, let's say, 0, 0, then it's only going to affect this one, 0, 0 also. But if it was, let's say, I don't want to make them the same in both coordinates. Let's say it's 2, 1. Okay, so let's say x is 2 now and y is 1. Okay, so which pixels over here are going to be affected? Well, blue, green, yellow, brown. Actually, sorry, not yellow. Blue, green, brown, and perp. So these 4. That's what we're looking at for that one. Okay, so actually maybe I'll just leave that there for now. Okay, so this is an x value of 2, a y value of 1. Which x and y values are being affected here? Well, the x's, it's affecting 0 and 1. And then for the y's, it's also affecting 0 and 1. Okay, so what's the connection between the two of these? Well, basically, if x minus 1 is within this matrix, like if that's within the range of what we can have in here, okay, well, first of all, it's going to affect x if it can, right? So if there's a 2, then it'll affect that. Like if there was some down here, then yeah, it would affect those, but there aren't. Okay, and then x minus 1, it'll affect those as well. Basically, the idea behind that is, so this one had an x value of 2, and we find that if we go up here or if we go down here, both of these are also going to affect this pixel here. The thing is, we have that issue with shifting the indices here. So basically, instead of saying like +1 and -2, +1 and +1 and -1, we're going to go with -1 and -2 just to accommodate for what we have over here. So basically, the indices that are affected here are the x value here, x minus 1 and x minus 2, and then the y value over here, y minus 1 and y minus 2. So all of those are going to be affected in here, but only if they exist in here, right? Like for y, yes, there was a 1. Yes, there was a 0, but there wasn't a negative 1. So that one didn't work. All right, so let's just choose one more random example to see if this actually applies, if what we're saying is right. Should we do this one here? Yeah, let's try that one. Okay, so what was the x value there? 0, 1, 2, 3. So x is 3, and the y value is, oh no, tell me it's also 3. Okay, we can't do that one. We want to make something. We want something that's going to be a little more unique, I think. It's fine. We'll go with this one for now. X equals 3, y equals 3, fine. And then over here, basically the ones that should be affected, well, 3, 2, and 1. And then the y values over here, 3, 2, and 1. So let's see, 3, 2, 1, those are for the x's. And then for the y's, we also have 3, 2, and 1. But the thing is, what do we actually have as valid numbers here? Oh, I haven't used that color. Okay, so do we have a 3? Like a row 3? No, definitely not. Do we have a row 2? No, we actually don't have that either, but we do have a row 1, so we'll hold on to that one. Okay, do we have a column 3? No, we don't. Do we have a column 2? Yeah, we do. And we also have a column 1. So that means the ones that are going to be affected are going to be in row 1 and column 1 and column 2. So in other words, these two over here. Now, is that consistent with what we had over here? It is, yeah, because this one lies within the purple square, within the fuchsia square, but not within any of the other squares. Okay, so this seems to be working. Let's bring this back over here and we'll delete that real quick. Okay, so I'm actually going to use some of our original algorithm over here. And specifically, it's going to be not that part. So basically, we've got our blurred image. The frame is ready to go for the blurred image. And all we need to do is get the values in there. So what we were doing before was basically going through the original, going through the blurred image basically, and then for every square, for every placeholder, like for every pixel basically, or pixel place, we were then saying, okay, which values from the original correspond to that? It is this one over here, this one over here, and that one over there. And then we take the average of those and we put it in there. Okay, so instead, we're going to go through the original again. We're just going to say for let x be assigned the value of 0, x is less than, we are reusing these now, so it's a good thing we declared them above. And for let y be assigned the value of 0, y is less than row length. And y plus plus. Okay, so we're going through each one, and we're going to say, we're going to do this. So we're going to put another nested for loop in here, and it's going to have these dx's again, and they're going to start at -2 now. Dx is going to be less than or equal to 0, and dx plus plus, and I'll do the same exact thing for dy. Let dy be assigned the value of, is there a negative in there? Yes, there is. Okay, -2, dy, not going to make that mistake again, and then dy plus plus. Great. Okay, so then basically, here's where things get a little more interesting. You remember I said before down here that because of our choice of having x and y begin at 1 and 1 sooner than they normally would, because of that, it was always going to be safe to do this kind of stuff over here, to say, okay, subtract 1, add 1, because we had room to do that. Now over here, it's not going to be such a guarantee. So I'm gonna do this. I'm gonna say let temp x, temporary x, be x plus dx, and let temporary y be y plus dy. So these are basically just the new values that we're getting from these. And now we do have to check. So we have to say, well, if temp x is less than or equal to 0, and temp x is less than call height -2. That's what it's got to be, right? Yeah. Yeah, I think so. Okay, and then temp y. Well, we'll start with the 0. 0 is less than or equal to temp y, and temp y is less than row length, sorry, minus 2. Okay, and let's just try to get a better look at these a little bit. Yeah, okay, so it's under this circumstance that we want to say, hey, let's do blurred image at temp x at temp y plus equals value. Okay, but what's value? Well, let value be assigned the value of image at x at y. It's just the value that we get as we're going through the matrix. And we're just, it's like we were talking about over here. We're saying, well, which one of the pixels over here, which ones of the pixels over here do I need to add this value to? So we're taking the value first, and then we're saying, well, which pixels do we have to add it to? And it's the ones that are going to pass this, the ones that are going to make this true. Okay, let's see if that works. Now, it's not going to give us our answers because we're still not taking the average. Oh, blurred image. Am I declaring that again? Let blurred image be this, blurred image dot push. Wait. Oh. Whoops. All right. So we'll get rid of that and we'll try to run what we've got upstairs. Okay, great. So we've got the right size. We've got numbers that look good. Yeah, excellent. Okay, so now the only thing is that what we're getting here is the sums. We're not getting the averages. So we need to take all these values, divide them by 9, and take the floor of that. So that's where map is going to come in handy. So we'll do dot map, and then the dot map is working on the matrix itself, right? So it's basically saying, okay, dot map contains two things. Blurred image contains two things. It contains an array up top and then another array below that. So we're saying row is going to be the element of blurred image. Because it's a matrix, its elements are not like the numbers themselves. The elements are these whole arrays. So this whole thing and this whole thing. Those are the elements of blurred image. But then what we really want to affect is the elements of each row. So we're going to map those and we'll say element, or actually, you know what, to be more semantic, it's sum, because that's what's in there right now. And what we want is math.floor of sum divided by 9, in other words, the average. So if we run that kind of double map strategy on our blurred image, now we find that it's going to pass all the tests. Okay, awesome. So we've got another algo working here. And there are a couple things I want to say about this. First of all, you might be looking at this and wondering a few things. So first of all, you might be wondering, why do you do it like this? You know, why don't you just say temp x is greater than or equal to 0 and temp x is less than column height minus 2? Well, to answer that question, it's because I come from a math background, right? So basically the idea is that I'm used to seeing something like this. 0 is less than or equal to, we'll say temp x is less than col height minus 2. I don't have room for the whole word there. But the main thing is that I'm used to these double bounds, right? You can't really do those in JavaScript. So with the way we kind of simulate it is this is now kind of representing the variable. So this variable has a lower bound of this and an upper bound of this. I just kind of like to structure it that way. That's a personal preference though. Okay, so then this is the thing that I used to always find to be kind of a major pain about these kinds of problems. Doing matrices where we're trying to get sort of like neighboring elements, neighboring like indices. I always found this part kind of annoying. And so I was delighted to find there is an alternative. So check this out. We're going to use the in keyword. Now we've used in before for like for loops and stuff like that, but I want to use it a bit differently. So let's say 2, -5, 1, 0, 9. Okay, so that's our array. Now I just want to use in here. So I'm going to say is 9 in A? Okay, so that's going to give us a Boolean. And it's saying false. 9 is not in A. And that might seem weird because, well, it's right there. Isn't it in A? And then we could say something like, all right, well, is 4 in A? And it's saying true, which is especially weird because 4 is not one of the elements here. So we're thinking, how's this thing actually working? But this might reveal it. If I delete that last element, now it's going to say, no, 4 is not in there. It's looking at the indices, okay? And if you ever forget that, just remember, in is for indices, in indices. Okay, so that's what we're going to use down here, because basically that's perfect. It's exactly what we want to check. So instead of all this, we could just say temp X is in blurred image, and temp Y is in blurred image at 0, because it's one of the rows there. And then if that's true, then it'll add the value. Okay, great. So that's working. That's good. I'm going to submit it. Hopefully it passes all the hidden tests. Suspense. Great. Okay, so nice job on that one. I'm happy with that algorithm. We'll move on to the next one in just a sec. But before we do, we'll take a quick break. See you soon.